So what I want to go over is the difference between a surface and a polysurface. And this is kind of fundamental to Rhino. I think it's kind of like the DNA. You have to understand um, how the software really works, and why it works kind of in certain ways, so that as we begin to model, hopefully, having this kind of fundamental understanding of the software, hopefully it's going to help you kind of problem solve your way out, as we're beginning to learn the software. Um, Rhino is a NURB modeling software, NURB, NURB, right? Now, there's two types of modeling softwares out there. There's NURB and there's Mesh. So when you look at, let's say, video games or some really great sci-fi movie, that's all created using using a mesh software. Getting tongue-tied. A mesh software is essentially kind of it's an algorithm. It's a software that's based off of an algorithm, which is a series of numbers that triangulates points. Super complicated, not really, but we don't really need to get into it. The point that I'm trying to make is that the mesh modeling software is a kind of very lightweight, very easy algorithmic kind of way of modeling, um, that allows a whole lot of curvature, and like these special effects, so that the file size at the end of the day is not large, right? That's kind of the key at the end of the day with some of these softwares is how, you need a computer that can handle it. So therefore, sure, the software can do certain things, but if you can't find a computer that can handle all of that, or if the final storage size is gigantic that you're going to need supercomputers, then it's not really appropriate. It doesn't really work. So mesh softwares, is a very lightweight type of software that allows all sorts of like complex curves and complex things to happen, in a light kind of file format, right? That's a mesh software. NURBS software is different. Rhino is a NURBS software, and NURBS is a bit more solid. It's a bit more like working with clay, a bit more working with kind of real, um, kind of solid objects, essentially. It's not an algorithmic, although there is parts of it, there's a lot of coding. But think of NURB modeling as if we're actually modeling something in the real world with, you know, wood or with foam core or whatever, something tangible, right? So keep that in mind as we're moving forward. Now, this first part of this kind of tutorial lecture, you can either just sit back and watch. Hopefully, I don't take too long. Or you could follow along in Rhino. Either way, it's entirely up to you. I do ask that you are going to submit this file at the end of the day, but the first part, if you get things wrong, it's perfectly fine. I'm not grading that part. I'm just going to grade the second part. I will let you know when the second part is. It'll be at the very end. Okay. So I opened up my Rhino file because it's a new file. First thing I'm going to do is type in units, make sure my units is set correctly. So I'm going to go to feet in inches, set it to 1/8, and hit OK. Then I'm going to go into the perspective mode. Let's make this a lot larger. Okay. And this first part is really just trying to explain the difference between a surface and a poly surface. Now, this is terminology. This is kind of Rhino terminology, but it's NURB modeling software terminology. But I want to show you what the difference is, and how to kind of, just kind of how the software exactly works. So I'm going to start off by drawing a line. Okay. So I'm going to go over here to and use a polyline. So I'm going to right click. Notice a little pull down that pops out. I have polyline line segment and it has a mouse next to it. That's letting me know if I click on this button using the left click, it's going to give me a polyline. If I use this button and click on the right click, then then it's going to create a line segment. Now, I am not going to spend all of this time going in, and explaining the difference on every single command. If you're interested, remember that you have the help button over here, and you could click on either one and you could learn what the difference is. Okay. But I'm going to left click so that I get a polyline. And I'm just going to click at random somewhere this kind of corner, doesn't really matter where. And I'm going to click and move the cursor to the right. Sorry, I have ortho turned on. Make sure you have ortho turned on. And I have my O snaps, which is my object snaps over here. And I have the gumball. Those are the only three that I have turned on. Move the cursor out to the right. Now remember, it's a click and let go of the cursor. Don't click and drag. So click, move my cursor out in the direction I want to go. And I'm going to type in, let's go 10 feet. So 10 apostrophe. You can look at my command line at the top, right? You can see I typed in 10 feet. Remember, all you have to do is start typing and you're good to go. Rhino will automatically assume that you're trying to go into the command line. So 10 feet, and I'm going to hit enter. Sorry, I'm going to right click. Like, sorry. Left click. Oh, I already started you guys off bad, didn't I? Okay. If you messed up, hit the escape key a couple times, start over, click, move the cursor out, type in 10 feet, and then left click. There we go. And that's all I want to do, right? Now I can hit enter. Sorry, I jumped the gun. In order to end a command, you have to click, right? I said it was click to start, click to finish. But you notice that it wanted to continue, right? That line wants to keep going. It's ready for the next dimension. So to end it, then we just hit the enter key on the keyboard. Okay, so I have a line. With this line, I can select it and I could use the command extrude curve. Now, extrude curve is going to be one of your most commonly used commands. Okay. So you can see up at the top left, extrude curve, and I'm going to hit enter. You could write that down somewhere, but pretty soon it's going to become second nature. So extrude curve, and what that's going to do is it's going to extrude that line. So I click enter, and now I can go up. Okay. So now I'm going to go ahead and specify a height. And now, right now, all I'm doing is moving the mouse up and down. I'm not left clicking, right clicking, or anything. I'm just going to move the cursor in the direction I want to go. Because if I go down, then let's say I go 10 feet, it's going to go 10 feet down. In this case, I want to go 10 feet up. So I'm just going to move the cursor up, and I'm going to type in 10 feet, enter. Okay. And so there we have our surface. Now, it would definitely help if we are in shaded view, not hidden line or wireframe. So I'm going to come over here and go to shaded view. There we go. Okay. So from this line, we were able to extrude that line and get a surface. Now I'm going to go ahead and copy this over 10 feet. And my goal is to create a cube. So I'm going to take this. Now, since I have the gumball turned on, make sure your gumball is on. Right? Now I see that. I can do two things. If you move your cursor over the arrow. So if I want to go 10 feet this way, if I move my cursor over that arrow, you get this pop-up that says move, extrude, copy, numeric entry, move gumball, right? And to the right of that, it has shortcut keys on the keyboard. So if I want to move, all I got to do is click. If I want to extrude this, I hit Control. If I want to copy it, I tap the Alt key. On it, enter numeric entry, then I click. And if I want to move the gumball, I double click. So in this case, what I want to do is copy it. So what I'm going to do is, it says tap the Alt key. I actually have to hold on to it until I click. So I have to hold down the Alt key and then click. Now, if you're on a Mac, it might be a different key on the keyboard. So whatever you have on your screen, press that button. So I'm going to hold down on the Alt key and then I'm going to left click. And now it's waiting for me to specify a distance to copy. So I'm going to type in 10 feet, enter. And there we have it. We created a copy. I'm going to create another line to create this surface over here. And again, using the poly line, I'm going to click. Notice that I have my O snaps turned on over here on the left, so I can go from end. So I'm going to, and I have object snaps also turned on, right? If I turn object snaps off, it doesn't matter what I have clicked on over here. It's not going to recognize any of my object snaps because it's turned off. So let's make sure we turn that on. So I'm going to click from one point and then click again. Remember, click to start, click to finish. And now that's what I was talking about before, that it just wants to keep going. It's ready for the next distance, but I'm done. So I'm just going to hit the enter key. And I'm going to do the same thing. I'm going to type in extrude curve. And notice that as I start typing it, do that again, all I really have to press at this point is E, and it generates it. Once it generates that command, I don't have to keep typing it. All I have to do is hit enter. Okay. And now I'm going to do the same thing. I'm going to go up 10 feet, enter. Okay. Now to copy this over here, we want to go in the red direction. So again, I could hit the Alt key and hold down the Alt key and then click on the arrow and then specify how far I want to go. Now, before I do that though, right now it's set to 10 feet, which makes sense. I want to go 10 feet. But notice here, it says 10 feet. It's going to go 10 feet, but because the arrow is facing this way, that means that it's going to go 10 feet in this direction. I want it to go 10 feet in the opposite direction. So if I want something to copy over to the opposite direction, I'm just going to come inside here and put the minus sign, so it's negative 10 feet. I'll hit enter, and there we have it. Okay. So now I have these 4 surfaces. Now I'm going to cheat a little bit, and I'm going to use the rectangle tool. I'm going to create a surface on the top and the bottom. I'm going to create a rectangle tool. Okay, again, object snaps are turned on, the endpoints. So right here it says specify the first corner of the rectangle. So I'm going to specify this, move my cursor over, and it's asking for the other corner. So I'm going to go right here. Okay. Now, I created a rectangle. I did not create a surface. In other words, I can actually grab it. Right, that's what I created. Let me Control Z to undo. But because it's on top of these surfaces, the lines themselves are overlapping the surface, so we don't really see anything, right? So if we place our cursor along the edge and click, I have a selection menu. And whenever you have this selection menu, this means that you can choose, you have overlapping geometry. So here it's saying, okay, do you want me to choose the curve or the extrusion? Okay. So in this case, I want to choose the curve. And now I have the line work. And I have this line work so that I can create a surface between all of the line work. And in order to create a surface from lines, I'm going to come over here to the surface creation tool, which is this one right here. It's kind of rectangle with 4 dots, but it has a pull down, like it has a little triangle on the bottom corner, right? I'm going to click on that triangle. And every one of these that has these triangles has a pullout with even more commands. Okay, these commands all relate to, remember in one of the previous lectures, the different workflows that we had. So this is our surface tools. So I'm sure that if we were to click on surface tools, we'd get even more commands past this, other than this. So it just really shows you how many commands exist in Rhino. Okay, so what I'm going to do is click on this command that says planar curves, and that's going to generate a surface. Okay. Now, really quickly, just so you know, if you ever do a command and ever want to figure out what was the actual name of that one command, as soon as you click on it, if you come over here, it tells you command planar surf. So if I ever want to recreate that without having to go over here and click, then I can go ahead and just memorize planar surf. Okay. Unfortunately, Rhino is all about memorization, and it's a command base. So any command based software like Rhino or like AutoCAD, which is another command based software, it's all about memorizing the commands. And so And that's really how you get better and how you get faster is by just kind of having a library of commands memorized. You're going to get faster. That's not to say that you can't use these commands and the icons. It's just going to take longer to go locate the icon than it would be to start typing PL, for example. Okay. All right. So now we have a planar surface. However, orbit, I need one at the bottom. So I'm going to select this. Now we've been using command, right? We've been copying using the gumball. However, there's another way we can do is just use the copy command. So I could select the object, so I left click on it. I'm going to type copy, and actually all I'm going to do is type CO, enter, and it's going to say point to copy from. So this is where you have to think ahead, right? Whenever we move or copy an object, we have to think what is going to line up with what, okay? Because if I just grab it and I move this, right, and I try to move this down somewhere, I'm never going to get to it. It's never going to come down, right? Even if I do come down, I'm going to have to kind of eyeball it. And remember what I mentioned about eyeballing, you never want to have to do that. So what we can do, type copy again, it's asking to point to copy from. In other words, where do we want to copy? Where is the point? Which point do we want to copy from? So in this case, I know that this corner is going to line up with that corner. So making sure that I have the object snaps turned on, I could easily just click this corner. And you'll notice that my cursor is now attached to that corner. And I'm going to come down and click on this corner right there. Okay. And there we go. It's copied. Now, once I'm done, remember, it just wants to keep, just like the line, it wants to keep going. So once we're done, we'll hit the Enter key. And there we have it. Okay. That was a lot of work for just a cube. Don't worry. That's not how Rhino works. I just wanted to do this as an example and as a test. So we've created a cube that's 10 feet by 10 feet by 10 feet. Okay. Well, we could do the same thing by using the rectangle tool. So I'm going to click the rectangle tool, and it's asking first corner of the rectangle. So I'm going to, let's go this way. I'm just going to click at random. There's my first point. Okay. Now I can try to kind of eyeball it, right? But I could also just type in 10 feet, comma 10 feet. So the first number goes along the that goes along the green axis, comma, and then 10 feet, enter. That does not look right. I did that wrong. Let's try that again. You know what? I think we shouldn't have done the comma. So 10 feet, enter. There we go. And then 10 feet, enter. I should have followed the commands. Okay, let me do that one last time in case that was confusing. So I'll start the rectangle. I click once. It's asking other corner or length. So we're going to do this once. So we're going to specify 10 feet, enter, 10 apostrophe enter, right? So that's the distance. The first number is along the red axis, right? Notice how now I can only move it this way because we've already entered the 10 feet. And then the second number, I'm going to type in 10 feet, enter. Okay. So now we have 4 lines, essentially, a square. I can select the square and type extrude curve. Now we did that for that one line, but now it's these 4 lines here. And we're going to go up 10 feet, enter. And you notice how quick that was. So now we have 4 surfaces. But you'll notice that there's something different about this one. Not in the way that it looks, but in how we click on it. When I click on this surface, it selects all of them. I click on this surface, it just selects that one surface. And that's because when we start using the extrude curve command, that begins to be part of the creating polysurfaces. Okay, poly meaning multiple surfaces. When we're extruding just a line, that's a single surface. That's an extrusion. Okay, this is going to make a little bit more sense, hopefully, as we move forward. So I have these 4 surfaces. However, they're still missing a top and a bottom. Now I could do the same thing where I can copy the surface or I could recreate the surface, right? But what that does is it creates a surface on the top and a surface on the bottom, but it doesn't really join it the same way that these four surfaces are joined. So what I can do is use a command called cap. And what cap will do is it caps these four merged surfaces, and it caps it as one entire object. So let me show you what I mean by that. Oh, select it, type in cap, and I hit enter. Okay. And now we have now we have an actual solid. Notice that when I click on it, just click on one surface, the entire object is selected. Okay. Now we could actually speedline this process. Is that a word, speedline? I don't think that's a word. I like to make up words, and speedline is going to be one that I just made up. So we're going to speedline this process, and we're going to create the rectangle, again, 10 feet, enter, not comma, 10 feet again, enter. We're going to use extrude curve. But before we go up, before we enter 10 feet, we take a look at the command line. And halfway down this line, there's a button that says solid equals no. So that means when I use the extrude command, it is not going to turn it into a solid. Now for my Mac users, that solid equals no is going to be on the left-hand side. If you don't see it, then that means you have to scroll down, find the little scroll bar, and it's going to be an option. It's going to be a checkbox for the Mac users. Okay. But for the PCs, all we have to do is click right here where it says solid equals no, and it turns into solid equals yes. Okay. Now remember, it's the same command. We did the same steps as extrude curve. Now I'm going to go ahead, except this time it says solid equals yes. Now I'm going to go ahead and type in 10 feet, enter, and it turned it into a solid without me having to tap it. Okay. So now that's why when I click on it, it selects the entire thing. All right, so what is the difference, right? I have three cubes, essentially two different cubes, because these two are pretty much the same thing. They were just constructed slightly different. What's the difference? The difference is that the way from a NURB modeling software perspective, this cube is not a solid cube. It's essentially 6 surfaces. Think of it as like 6 sheets of paper that are just kind of taped along the seams to make this cube. It has an inside, and I can take it and I can delete it, and you can see it's paper thin, right? Whereas this is a polysurface. It's a solid object, okay? Think of it as a solid kind of mass, whereas this is just 6 sheets with a void in the middle, okay? Now, yes, we can still get inside if we try to get really clever with it. And now, as we get bigger objects, you'll be able to get into them. But we could still have like an interior void. But Rhino recognizes this as a solid object. And this is the way you want all of your modeling objects to be constructed. Okay. I'm going to do something. I'm going to copy this. Actually, I'm going to copy both of these. I'm holding down the shift key. That allows us to do multiple selections. I'm going to copy, type in copy, and I'm going to click on this corner, just kind of move it around and click right back. And then I'll hit enter. So in other words, what I did was just create 2 copies on top of one another, which is why when I click here, I get 2 options, right? Now I want to show you, actually, you know what, I'm going to do the same to the top as well. So move it around, copy, right? This is just to show you an example, to hopefully kind of underline the point I'm trying to make. I already mentioned that when you click on an object and I get the selection menu, it means that you have 2 surfaces, 2 objects, 2 something, and Rhino's trying to figure out, well, which one do you want to select? Okay. But you'll notice that my selection menu here states 2 polysurfaces. That's good. That means I have a polysurface. When I come over here, it tells me two extrusions, right? So that's how you know the difference between an extrusion and a polysurface. Now, when I click on the top, it tells me two surfaces. How and why is that different? Well, if you remember how we created these, this one here was created by creating a line and then extruding that line up. That's why this is an extrusion. This one, we use the planar surface command. That's why it's called a surface. So when you go about modeling and you find yourself with selection tools and with these selection menus, and it's going to happen, you're going to get three different options. You'll at some point, depending on how you modeled, you'll have different options. It'll be between a polysurface, a surface, and an extrusion. So hopefully moving forward, whenever this happens and you see these three different kind of terms, you now know the difference, right? If it says extrusion, it's because it wants to select something that was created using an extrusion command. If it says surface, it's because it wants to select something that was created using a polysurface command, right? And if it says polysurface, then it's referring to an actual object. Now, if you ever find yourself in a situation where you have, and it's going to happen because it happens to all of us, multiple selections, but you just say, wait a minute, I only created one. I don't remember creating two cubes. If they're both the same thing, and as I toggle through, the polysurface itself doesn't change, then what I can do is just select the polysurface, select either one, and then hit the delete key on the keyboard, and it's going to delete the copy. And now when I click, you'll notice that it's not giving me a selection menu because there's only one thing to select. Okay, so hopefully now we kind of have an understanding between the difference, what is a polysurface? It's an actual object, it's a solid object. What's an extrusion and what's a surface, right? And that when we model, we want everything to be modeled as a poly surface. All right. And if you ever find yourself in a situation where it's close to a poly surface because all the walls are joined, but you're missing a top or a bottom, then you use the cap, C-A-P command. Okay. I'm going to take this poly surface and I'm going to copy it over here. You say, well, okay, what if it's a poly surface, but now I want to turn it back into a surface? That's when we use the command explode. It's a bit dramatic of a term, but we're going to use the command explode. Okay. Now, I rarely will use the command explode, but we do use it from time to time. And for this sake, I'll kind of explain what does explode do. I'll type in explode, hit enter, and it now took this poly surface and broke it into individual surfaces. Okay. It'll probably call these extrusions because we use the extrude curve command to create it. So now it's using the explode command has turned the poly surface, essentially turned this cube into this cube because I can now take this and delete it, right? And now it's no longer a solid object. Well, you say, well, what if I want that to be a solid object? Now, we typically don't explode solid objects because it gets really difficult to turn something like this into a polysurface, right? To turn it back into a polysurface, it's really difficult, right? Essentially what you have to do, and it's not going to look difficult right now, but essentially what you have to do is select all of the surfaces. Holding down the shift key, I can select all of these surfaces. Right? And don't forget the bottom one. Okay. And we have to use what we call the Boolean union command. And we'll talk more about the Boolean union command later. Right? But that's going to turn that back into a poly surface. Right? But notice how difficult that was where I have to click every single one. I'm going to explode again. Now we're back to the exploded view. You can do a cross window okay, where I click and drag the cursor, make sure everything is within my box, so that everything is selected, and then do the same thing, right? Use the Boolean union command and it'll turn it in. However, the reason why I say it's difficult right now, it's just a cube, right? And I could easily do a cross window. I could easily click all the surfaces because it's easy to get to. But let's say you're building a 2-story residence and you accidentally exploded the kitchen cabinet that is attached to the floor, or that's butting the floor and butting the 2 corner walls, that's next to a window. It's going to get very, very difficult to try to get in there and try to click on the correct surfaces, because you're also going to have the wall surfaces on top of one another with the cabinet surface, and you'll have the floor surface overlapping the floor of the cabinet. So you're going to have to select every single surface, and that's going to be a nightmare, right? That's really going to test your ability to kind of get inside the walls, all sorts of things. So you really want to try to avoid exploding a polysurface, unless you have to. So, or unless it's extremely intentional. Now, I'm stressing this part a lot because despite never really talking about exploding objects in any of my lectures or tutorials, I always get questions about exploded objects. Somehow, somewhere, students will go onto other YouTube accounts and hear the word explode and think, oh, that's what I got to do, right? Um, so don't do that. Essentially, this is all just for me to say, don't do that. Unless, again, it's intentional. Okay. Now, let's go back to exploding. Explode. After I've just said, don't do it. Because another common thing that students will do is use the group command. Somewhere along the line, they hear the group command. So let's talk about the group command. I can do the same thing as the Boolean union, right? Select the whole thing, type in group, enter, and click, and boom, there we go, right? It looks just like a poly surface. However, what we ended up just doing right now with grouping is we grouped 6 surfaces into one, so that when I click on it, it selects 6 surfaces. That is not the same as turning it into a poly surface using the Boolean union command, okay? Because this is still 6 sheets of paper taped together at the seams. This is an actual solid object. Okay, so grouping does not turn your object into a poly surface. Grouping just groups all of the surfaces into one, so that makes it easy for you to just kind of move this around. Okay, that's it. Okay, so that's the lecture part. I'm going to go ahead and delete everything. Now is the assignment part. It's going to be super simple, very easy, shouldn't take too long. But now's the time that, if you want to go ahead and start following along in Rhino, or if you want to watch and then go back to it afterwards, now's that time, right? Because you're going to submit. This is what you're going to submit. All we're going to do is a simple outline of a building and extrude it up. Then we're going to explode it, and then we're going to put it back together. Okay, so I'm going to use the polyline tool, and I'm going to start anywhere in the corner. I'm going to make sure that ortho is turned on. I'm going to click and I'm going to go up, okay, along the green axis, and I'm going to type in 30 feet, 30 apostrophe, okay. Notice that when I move my cursor, doesn't matter where I move it to, because I've typed in 30 feet, that point is set. Right? It's not going anywhere. The only time it'll move is if I move my cursor all the way over here and say, like, oh, you want to go this direction. Cool. But I want to go this way. I'm going to hit left click. Okay. Now, up until now, we've been hitting enter to escape, but we're drawing a building outline, so let's keep it going. This side here, we're going to go 10 feet. Okay, and left click. Then we're going to come straight down, and we're going to go 15 feet. Left click. We're going to go over to the right. We're going to go another 10 feet. Left click. We're going to come straight down. Notice that right here, let's talk about this really quick. Notice that the cursor is, all of a sudden I got this blue kind of line going down my screen, right? And that's because Rhino is kind of thinking that like, well, wait a minute, maybe you don't want to go down, along to the red axis. Maybe you want to go down the blue axis, which is essentially going down, like down, down, right? Which is not what we want. So just make sure you have to be really careful, especially when we're starting off, that when we're entering numbers and we're moving the cursors, it gets a little tricky because students end up, you have a natural intuition to look down at the keyboard, and now you're not looking at the screen anymore, right? And just, as you can see, just slightly moving the mouse will change it. And so if you accidentally bump the mouse as you're beginning to look down onto the keyboard and you type 10 feet and then you hit enter, you're going to go straight down. And that's where students make mistakes. So if you're going to look down, just go ahead, type in 10 feet, right? And then come back up. Lift your head back. Sorry, it's not 10 feet, it's 15 feet. I'm going to type in, let me erase that, 15 feet. Okay. Come back up before you actually do the left click. Make sure that that's where you want to go. Okay. And now over here, I'm just going to go ahead and click to this point right there. Okay. So there we have kind of the outline of a building. At this point, what I'm going to do is use the offset tool, okay, or the offset command. So offset, I'm going to select, and what the offset does is it offsets the line work, inward or outward. Okay. So I'm going to select the line so that Rhino knows what it is I'm going to want to offset. I'm going to type in offset. Actually, all I have to do is type off and offset pops up, and I'll hit enter. Now it says side to offset, and then there's also distance right here. So what I'm going to do is I want to offset inward, and I'm going to type in 6 inches. Okay. Now I haven't clicked on anything. Once I've typed in the distance and I move the cursor inward, then I'll go ahead and left click. And there we have it. I can hit the escape key to get out of the commands entirely. And now I have 2 sets of lines. Right. I'm going to actually select both lines by just doing a cross window. Now, really quickly, I want to point out that we have 2 cross windows. A cross window is when I left click on the cursor, hold down, and I drag. There's actually 2 cross windows. If you pay attention, when I click and drag to the left, I get a square with kind of dashed lines, which is different than when I click and go to the right, it's a rectangle with a solid line. The difference is that a left click, the dashed lines, will select anything that is within the box and what the line is touching. So it's touching all of this, right? Because it's touching these lines, it's fine. The other one will select everything that is within the box and nothing more. So the entire object has to be inside the box. So when I let go, it didn't select anything. It didn't select anything because the entire object of this line is all of this. If I want to do a cross window with a solid, then that means I'd have to start all the way over here and put everything inside the box. Then it'll select it. Even if I miss just a little bit right down here, it's not going to select it, which is very different than a cross window with the dashed lines. As long as it's touching the line, it's going to select it. Okay. So here we go. We're going to go ahead and select that. At this point, I'm going to type in extrude curve. It's asking solid is set to yes, and I'm going to go up 10 feet. Enter. And just like that, we have walls. Yay. Okay. And not only that, best part is that it's a polysurface, right? So now what I want you to do is copy this over. So we're going to select this. We're going to copy this over this way. So I'm going to, that's interesting. Oh, there we go. That little command box wasn't popping up a second ago, but it's popping up now. I want to copy, so I'm going to tap the Alt key, actually hold on to the Alt key and then click. After I've clicked, I don't have to hold down the Alt key anymore. This time I'm going to go 50 feet. There we go. And now that I have this, I'm going to explode this. Hit enter. Okay. And really what I want you to do is see what is the difference. Okay. And the reason, again, there's a reason for this madness. When we start building buildings in Rhino, I need you to be able to recognize when something is wrong. When you're clicking and you recognize and see like, oh wait, only the surface is being selected, as opposed to the entire object being selected. Okay. There's going to be times where um, there's going to be times when you start to recognize something being off. And this is what this whole assignment is about, is just recognizing what does a correct object look like? What does an incorrect object look like? And now that we have an incorrect object, how do we fix it? So we're going to do that cross window. And this time, because if I do a cross window just here, it does not select all of my objects, right? Because these are individual pieces. Okay. Um, so you'll see that even though it looks highlighted, let me hit the delete key. That's actually what was selected, right? It's a bit deceiving because the top surface here is an entire surface. So when I do a cross window, it selects all of it. And if I select both the top and the bottom, it looks like everything is selected because it's also selecting the bottom surface, right? The one down there. So it looks like everything's selected. But when I hit the delete key, you'll see that not everything was selected. So again, to select everything, the entire object has to be selected. And we're going to copy this over again, hit the Alt key, and type 50 feet, enter. Select the entire object. Okay. If we accidentally just select part of it, and we try the Boolean union, which is this one here, it's not going to get everything, right? And the last thing you want is to do a Boolean union and still have pieces missing, because at that point, you're never going to figure out that that you have missing surfaces to your Boolean union. And later on, we're going to have to start doing things to this poly surface, and it's just not going to work for you. Because the next kind of steps of cutting out doors and windows and things like that, the next step requires these objects to be poly surfaces. And if there's anything wrong with it, the command's not going to work for you. And if you don't actually select everything, you're going to click and be like, well, Javier, it's a poly surface. Look at that. It looks perfectly fine. When in fact, it's not. So I'm going to undo back to where it's in the individual surface. Make sure, the point of this is make sure you select the entire object. And then come over here and click Boolean Union. Okay. And so this is what we have. We have the actual poly surface. We have it exploded. And then we have it Boolean unioned again. And this is what you're going to submit. You're going to hit File, Save As, make sure you save it as a .3dm file, and you're going to submit the 3dm file, the actual Rhino file. Okay. Hopefully this is helpful. Good luck, and don't hesitate to reach out if you have any questions.